In this video, I'm going to be showing you how to calculate the energy savings per year and the cost savings per year of a boiler if you increase the efficiency. And we're going to be looking at that for a range of efficiencies from 0.7 to 0.9. So currently the boiler is operating at 0.7, and we want to look at, okay, well, what will the energy savings and cost savings be if that efficiency is increased up to 0.9. So we're going from a range of 0.7 to 0.9. And then, so that's what this says for the boiler, and this is from problem 2-59, and this is from the book Thermodynamics and Engineering Approach, the 8th edition. And so for problem number 59, what we did was we had a boiler that was operating at 0.7, and it was tuned up to increase the efficiency to 0.8, and then we calculated the energy savings for that and the cost savings for that. And so this problem is doing the same thing, except this time we're calculating the energy and cost savings for a range of efficiencies instead of just one. And what we're also doing is we're going to calculate what the cost savings is for 3 different unit costs. So the first unit cost would be $4 per million BTU. The next unit cost is going to be $5 per million BTU. And the next unit cost is going to be $6 per million BTU. And what we want to do is we want to plot the boiler efficiency versus the energy savings in BTU per year. And we also want to plot the boiler efficiency versus the cost savings per year. And this plot will have 3 different plots because we're doing the calculations for 3 different unit costs. The equations we're going to be using are, first of all, the energy savings can be calculated by taking this Q in, which is the heat input to the boiler, and this will be multiplied by the percent increase in efficiency, and that's multiplied by the number of hours per year that the boiler is operating. And the next thing we're going to calculate is this cost savings, and that's equal to the heat input of the boiler multiplied by this percent increase in efficiency multiplied by the fuel cost, and this is where we're going to have 3 different fuel costs, so we'll run this calculation 3 times, multiplied by the number of hours per year that the boiler is running. And if you look at these equations, you can see that the cost savings is equal to the energy savings multiplied by the fuel cost. And you have to be kind of careful with this equation because the fuel cost is per million BTU. So this million BTU needs to be taken into account when you use this equation. And if you want to pause the video real quick and write down these equations, that might help as I go through this Matlab code and show you how to run these calculations in Matlab and how to make these plots. So if I go over to Matlab, so this is what you get when you first open up Matlab. So you have your command window, your workspace is where your variables and the value of them show up. And you can type directly into the command window, but the problem is if you're doing something kind of long, like what we're doing, you want to write a script. And so the command window is more for like typing really short things, like if you just do it, like want to calculate what a couple numbers are real quick, you can use it to type MATLAB commands or for debugging. But for what we want to write a MATLAB script file, so we're going to click on this box up here that says New Script, and then it comes up with this editor. And the thing with this editor is you can type MATLAB code or script in pretty much any text editor. Like for instance, you could use like Notepad++ or Emacs or like whatever you want to use, and you would just save it as a .m file. So MATLAB script files are .m. I think it's easier to just write MATLAB files in the MATLAB editor, but it's an option to write them in different editors, so you're not bound to this editor for writing MATLAB scripts. So the first thing I want to do when I write MATLAB scripts, I always, first of all, start with these two commands, clear CLC, and what that does is it clears your workspace and it clears all your variables. So then if you're editing code or changing things and you change a variable, it doesn't have the old variable saved still, because that could potentially mess up your code, especially if you have an array that's, I don't know, like really long and it has a bunch of values saved, and then you change your code to where it's shorter, but when it reruns it, it'll still have the old longer values saved, and so that could cause errors down the road, and it can be hard to figure out what's going on. So I just clear everything right from the start. And then I want to write what this code is doing. So this is, I'm just going to call this boiler efficiency study. And then the next thing I want to do is I kind of want to build a skeleton of what the code is doing, so then I can just put things in. So the first thing that I'm going to be doing is plotting the efficiency of the boiler versus cost savings. And also, these are comments that I'm putting in, so this percent sign is how you do a comment in MATLAB. So the program, when I run the program, anything with that percent sign won't be read. So, and then the other thing I'm going to be doing is I want to plot the efficiency of the boiler versus, actually, I screwed this up. This first one is plot the efficiency of the boiler versus energy, savings. And the next one is I want to plot the efficiency of the boiler versus cost savings. So then for the efficiency of the boiler versus energy savings, the first thing I need to do to make that plot is I need to calculate the energy savings. And so I'm going to do that. I'm just going to put in the equation, and then I can start filling out my variables. So, because I already know what the equation is, so it might be easier to start writing that and then just put in what you need. So energy savings, so I'm going to call this variable energy savings, and this is actually going to be an array because it's going to be calculated for a range of efficiencies. So first of all, if we go back to that equation, I had q dot in, so I'm just going to call that q dot in. And then since I'm multiplying by an array, I need this dot times. And so then I'm going to have, and I haven't created this array yet, but I'm going to have efficiency, and I'm just going to call this efficiency percent increase, and then dot times, and then hours yearly. So then looking at this equation, I need to specify what all of these things are. So I'm going to go back up here, and first of all, I know that capital Q dot in is equal to 5.5 times 10 to the 6th, and this is BTU per year. And then I know what the old efficiency is because it's given, so the old efficiency old is equal to 0.7. And so now I need to create an array that holds my new efficiencies, because if you remember, I'm calculating this for a range of efficiencies, so it's not just one. So I'm going to say efficiency new is equal to linspace, and this linspace command will create an array with a specified number of digits between two digits. So for instance, this problem said to do these calculations for a range of efficiencies between 0.7 and 0.9. So what I want to do is say, first of all, it starts at 0.7, it goes to 0.9, and then I'm just going to say 20 points. So this linspace command will create an array with 20 equally spaced points between 0.7 and 0.9. And if you can't remember how to use certain Matlab commands or functions, you can always go to the command window. So I'm going to click down here on the command window, and you can just say help, like in this case I'm using linspace, so help linspace, and then it will tell you all about it. And there's also a lot of information online for Matlab, so if you can't remember how to use something, just Google linspace and you'll get all the information you need to use it. So then I want to calculate this efficiency percent increase, because I have everything I need for that. So I'm going to say efficiency percent increase is equal to, and then this is going to be the new efficiency minus the old efficiency divided by the new efficiency. So I have efficiency new minus efficiency old, and I need dot divide because I'm dividing two arrays. Efficiency new. Okay, and then I think the only other thing I need is this hours yearly, so I'm going to change this to yearly hours. So yearly hours, and this was given as, let's see, where is it? 4,200. So 4,200, and I'm just going to specify that this is hours per year. Okay, so I think I have everything for this calculation, so I should be able to make the plot now. So I'm just going to say plot. So the command for plotting in Matlab is plot, and then you see it comes up with this information again about how to use it. So first of all, X is going to be the efficiency new, and Y is going to be this energy savings that we just calculated. So I'm just going to put energy savings. And I'm going to run this real quick to make sure everything works. And it's just going to ask me to save it. And then when it comes up with this change folder, it just means that your file isn't saved in the same folder as the Matlab path. So all you have to do is just say change folder and it'll run it. And that looks good. So now I'm going to do the second part of the problem. So if I go down here where I have plot the efficiency of the boiler versus cost savings. So this is going to be calculated for 3 different unit costs. So I need to put those in. So I'm just going to call the first one fuel cost 1, and that's equal to 4. And then I'm just going to say what this is. This is $4 per million BTU. And I'm going to put the next 2 in, so I'm just going to call this fuel cost 2 is equal to 5, and that is 5, I'm just going to put a comment saying what it is, so $5 per million BTU, and then fuel cost 3, and this is equal to 6, and then that's $6 per million BTU. And then if you remember going back to those equations, I'll just pull them up real quick. I said that this cost savings was equal to the energy savings multiplied by the fuel cost. And so we have the fuel cost and we have the energy savings, so I can calculate, I'm just going to call it cost. So I'm going to do this 3 different times for each fuel cost. So I have cost savings 1 is equal to the energy savings, and this is multiplied by fuel cost 1. And then I also need to divide this by 10 to the 6th. And the reason why is because if you remember, this fuel cost is the cost per million BTU. So you need to take that into account in your calculation. So now I have cost savings 2 is equal to energy savings times fuel cost 2, and this is divided by 10 to the 6th. And I have cost savings 3 is equal to energy savings, and this is multiplied by the fuel cost 3, and that's divided by 10 to the 6th. And then I should be able to plot these, so I can just say plot. And so I'm still plotting the new efficiency on the x-axis, so efficiency new, and I want to plot the first cost savings on the y-axis, so cost savings 1. And then I want to put all 3 of these plots for the different cost savings on the same plot so they're easy to compare. And so the way I put 3 different plots on one figure, so Matlab has what they call a figure, and the figure is what you put the plots on. And so normally if I just put in 2 more plot commands without telling it hold on, then it will plot 3 different figures. And so I want it to plot 3 plots on one figure. So I have the figure, and I plot the first plot, and then I say hold on, and then I can put the other plots on there, and it will continue to plot them on the same figure. So for the second one, I have plot, and so I still want the efficiency new on the x-axis, and I have cost savings 2 on the y-axis, and then plot efficiency new cost savings 3. And then this should be pretty much ready to run, except I want to do one more thing, because right now I have this plot here and I have these plots down here, and I want to make sure that Matlab plots them on different figures, and it should, but just to make sure, I'm going to put figure above this plot and figure above this plot. And so what that does in the code is this tells Matlab to open a figure, like it opens an empty figure, and then it plots whatever comes next in this figure. And then once it sees this figure command again, it opens up another blank figure, and then it will plot whatever plot commands I have here in this figure. So this one will plot, since I have this hold on, it'll plot these 3 plots on this figure. So then if I run this, and so these are the plots I get. And so the next thing I want to show you how to do, that's the code. The next thing I want to show you how to do is how to use plot tools to make your plot readable and look good. Because right now we have no idea what these are. Like we need to label the axes, and maybe make the fonts a little bit bigger so they're easier to read. And what I'm going to show you in plot tools, you can write code to do all of this, but I think for beginning with Matlab, it's easier to use the plot tools to edit your plots. So you do that, you go to Tools, Edit Plot, double click on the plot, and it comes up with this editor, and this is just the plot tools editor. So the first thing I always do in here is I make my plot square, because Matlab likes to make rectangular plots and they look really bad. And for homework problems and things like that, this doesn't really matter. But if you start writing, like if you're with a company or you're doing research and you start having to create plots to present data, if you know how to make your plots look good, you're going to be worlds ahead of most people. So I'll just show you how to do a few things in here. First of all, I want to put a X and Y grid on this. You do this, there's this thing here called grid, and you just click X and Y. And that makes this plot a lot easier to read. So for instance, if I want to look at the 0.8 efficiency, and remember this was the energy saved plot, then it's like, what, 10 to the 9, or 2.9 times 10 to the 9 BTU per year. So that just makes this a lot easier to read things off the plot. So the next thing I want to do is change the font, and I almost always change it to Arial, unless some places will specify Times. But anyway, I'm going to change the size to 14, so because then you see these numbers are a lot easier to read. And then for the x-axis, the limits here, I only calculated values between 0.7 and 0.9, and so I want to actually change this upper limit from 0.95 to 0.9. And you do that with this x limits, so you can see it's 0.7 to 0.9 now. And then I want to put a label on the x-axis, so I'm going to call this efficiency, and then I'm going to put in the Greek symbol eta, and you just type \eta, and it will automatically put that in. And then if I go to the y-axis, the limits on this axis already look good, so I'm going to leave them how they are. But I want to put a title, and so this is the energy savings, and this is in BTU per year. And then I want to put a title, so I'm just going to call this boiler efficiency versus energy savings. And I'm going to move this over so it's not covering up the 10 to the 9. And then another thing you can do is you can edit what this line looks like. So if you just click on it, you'll see that it highlights it. And then I can come down here and has plot type. And Matlab has a lot of different plots. So like, for instance, I could do a bar plot, but that's going to look terrible for what we're doing. Area, stairs, stem. We want to do a line plot. And then I can change the color. So I'll make it blue. Change the thickness of the line. And then you can also put markers on. So if you click on this markers, it'll come up with a bunch of options. I'm going to put a circle for now. And we don't need this for this, but what this does is it puts a marker everywhere that I calculated this energy savings for each new efficiency. And so I'm going to take that off because we don't need it for this plot, but if you want to put markers, that's one way that you can do it. And so I think this plot looks pretty good. So the way you save it is you go to File, Save As, and you can save this as a JPEG, or I like to save them as EPS, because then you end up with better figures for papers and things. But you can also save it as a .fig. So a .fig is a MATLAB figure file. So then when you open this later, it will open this figure directly in Matlab in this plot tools, and so then you can edit it some more. So I want to go to this next plot, and I'm just going to say Tools, Edit Plot, double click on it, and then now they're both open in plot tools, so you can see first one and then this one. So I'm going to do the same thing on this. The first thing I'm going to do is make it square. And then I want to change the font to Arial. and I'm going to make it 14 so it's easier to read. And then if I go to x-axis, I want to change these limits again because I'm only calculated to 0.9, so I'm going to change the upper limit to 0.9. And then I want to put a title in, and so this is still, and I need to move that up. So this is still efficiency / ETA. And then if I go to the y-axis, I'm going to put in the title for this. So this axis is the cost, savings, and I'm going to say cost savings per year. I'm going to calculate year, or put uppercase for year. And then the title, I'm going to just put boiler efficiency versus cost savings. And I'll move this over so it's not covering up the 10 to the 4th. And I want to put the X and Y grid on here again. So you see grid, I'm just going to check the X and Y. And I also want to make these lines thicker. So I just click on it, and then I get this line, and I can just click on, like this 0.5 is, what is that now? So I'm going to make it 2. I'm going to do the same thing for all of these. So you just click on each one. And I might change the color of this one too, because yellow is hard to see sometimes. So I'm going to change this one to black. And then the only other thing I need, so we have 3 different plots here, and we need to let people know what each one is, and so we want to put in a legend. So I go up here to Insert, Legend, and I'm going to move it over so it's not covering up the plot. And then the first one, this was the $4 cost, so, oh, and I just double click on this to get to where I can edit it. So $4 per million BTU. Whoops. And then the next data 2, the second one was $5 per million BTU. And this third one was $6 per million BTU. There. So I think this plot looks pretty good. I mean, just looking at it, a user, because the goal for plots is to make it so, because you know what the plot is, but other people might not. And so you want the user to be able to look at this plot, and right away they're like, oh, it's the boiler efficiency versus cost savings. And so then they can see really quickly that you have the efficiency on the x-axis, you have the cost savings per year on the y-axis, and then each of these plots is a different cost per million BTU. So for instance, if you wanted to see if your cost was $5 per million BTU, and let's say your efficiency was 0.8, you could just go up here and then, actually I'm going to say 0.85, so then you just follow this up and over, so then that would be 2 times 10 to the 4th dollars per year. So what is that? $20,000 per year. So that's, and then you can just save this plot the same way as the other one. So that's what I wanted to cover. Whoops. That's what I wanted to cover in this video, and if you have any questions, feel free to comment or reach out to me. Thank you.